Yeah, so this won't be a talk on Ukraine, I'm sorry, but I'm really glad to be here. A few words about me. So I'm a software architect, specializing in PHP-based applications. My coding addiction is financed by a company called Arbor Education. And I'm also one of the organizers of PHP Serbia conference. And I was wondering whether by any chance someone attended this conference a week ago. Yeah, cool. One person. I expected more, but... So I decided to talk about something that is not an easy topic in PHP and in programming in general. So I believe that things such as dealing with exceptional conditions, use of exceptions, error handling. So these are all kind of stuff for which you won't find many useful resources and explanations online. So this talks aims to change this. So for the beginning, I would like to remind you of one phrase, well-known phrase in software development known as a happy path, and how we as developers kind of naturally gravitated towards to it, both when writing our code and testing it also. So we are giving too much attention to this default scenario of application execution. We often neglect that other way things can go. So consider this simple example where we ask user repository to give us a user by his name, and we want to notify that user about certain notification in case that user is subscribed for receiving that notification. So it's a pretty straightforward code. So that's a happy path, right? Regardless of whether this will be executed or not. But all of a sudden, you know, something like this happens, right? And who has been here? Yeah, we've all seen this. And fixing this is easy. So we put this null check, of course. But the problem with this is that this null check is error prone and it's ugly, you know. I bet that you've seen and that you're working on an application where every other line is checked for null, you know, and that's a disaster. So the problem with this is not that this null check was missing, right, but that the author of this user repository designed it in a way so that it shifts the burden upon caller, right, by making this return type nullable, right? So, and I've even seen that people do this kind of thing. So they, instead of returning null, they also return some odd value like return codes or flags, and they write some silly description in a comment. But that's not how we write our applications, right? I mean, we do not write comments. We communicate through code, through syntax, right? So my advice here, my first advice in this talk would be not to return null. So do not return null from methods. You know, you're going to end up with flood of repeated null checks, and if you forget to put only one, that can have disastrous consequences, as we've seen. And of course, this is not a revolutionary idea, you know, because in fact, I just agree with something that was stated long before me by some prominent experts in our field, like Uncle Bob in his Clean Code book. Who has read this book, right? Many of us. And then in that same book, Uncle Bob also suggests two alternatives. So one is to throw an exception, and other is to return a special case object. So let's examine both. So first solution would be to throw an exception as part of your API contract, some meaningful exception, and guide the consumer instead of returning some values for which he probably won't be prepared for. And now the user does not need to look into the implementation and all to know how to put himself against using your code. And of course, we can now safely put this return type to remove nullable return type, actually. The problem with nullable return type and why it is vague, is that that method still may look like it has a clear definition, but it doesn't say why it returns null. In this case, it is very expressive, it is very descriptive to what's going on, with this code and how do you use it. Hopefully one day, PHP is going to have real annotations, right? So this method definition could look like this, because I hate doc blocks, for example. I hate writing those, and with new features that get introduced with newer versions of PHP, we can safely remove, for example, doc blocks for properties in our classes, right, with a type properties feature. Anyway, now we can change the original code to look something like this. So we now need to deal with that exception either in line or in some other place. But the try-catch blocks are ugly in its own, right? They kind of mix normal and error processing, so they kind of blur the intention in this code. It's now kind of more harder to see what is going on with this code, what this code does. So my advice would be to always split try and catch blocks into separate methods to have a clearer idea what those two blocks do, Special case is the second alternative. A special case is a pattern that was described in Martin Fowler's book. It is also known as null object. So if you haven't heard for special case, you probably heard for null object. Those are the same things pretty much. And in our example, it would work. So how it works is that you create a class that exhibits some default behavior by overriding, in our case, a user entity with some meaningful values for our special case of user not being found by a repository. And you return that special case object that has the same interface as what the caller expects, right? So now we can safely remove those null checks because our code will continue to work. It will continue to function, right, regardless of whether user was found here or not. So, but still, there may be plenty of cases where you need to check where you may be interesting to know whether that user repository has failed to find a user. And you may be tempted to do something like this, right, using instance soft check, but I suggest that you aim for something like this instead, and I'm going to explain why soon. So in order to do this, you create this static factory method in the user class itself that makes sure that only one and only instance of an user is created. So you don't want to let multiple special case instances be creating during your application lifecycle. So this is cool, but if you want to be really cool, you will take advantage of anonymous classes feature that was introduced in PHP 7, right, to simulate what exists in some other languages that is known as private nested class, right? And now, not only that you made sure that there is only one instance of this special case, but you also made sure that no one else can create instance of a special case object. And that's why that check with instance of wouldn't work, because there is no class. It is private, it is anonymous, it is nested. So, Uncle Bob obviously hates nulls, right? Because what he also has to say in his book, that returning null from methods is bad, but also passing null into methods is much worse. And in PHP, it is possible only if the code allows it, right? As in this example where we have this order object consisting of a product that some customer is buying, and that order can have optional discount attached to it. An example of a discount will be this premium discount, which cuts the price by 50% when it is applied to a price. So, but you're noticing that author of this code, he has understood that requirement literally, and he translated that to his code by making this discount parameter optional. So consequently, he needs to have this ugly null check in method for calculating total order price. So how do we fix this? So we want to be here, right? We want to make everything mandatory, make all the parameters required. But in order to, but we still need to satisfy that business requirement of a discount being optional. So how do we do that now? What do we need? Anyone? Exactly, yeah. So you create a special case object that simply does nothing with price. And now this code becomes more readable, more expressive of what's going on when there is an order without any price. So this is just a naive example to show you, to remind you of all those places where you may have not one of these ugly null checks in your code, but dozens of them, right? So now someone may be wondering whether you should use, as an alternative to dealing with nulls, exception or a special case. Well, special case can remedy most of the exceptional conditions, right, as we've seen, because special case actually encapsulates exceptional behavior. So that example that we've just seen, so special case over optional parameters all day long, right? That's where special case really shines. So for those default strategies in your code. On the other hand, exceptions, when we throw them, they do break normal flow of our application, but sometimes we do not want to interrupt that flow. So again, that's maybe a situation where you want to use a special case, as in that example where we want to notify user about certain notification. But if those checks for null object, that we've seen, if user equals to user unknown, if they start to pile up, that may be a code smell that you should have. And if on those checks you start doing things such as logging errors or maybe throwing another exception, that may be a signal that you should have thrown exception at the first place. Because exceptions also typically aims to emphasize a violated business logic rule. So let's talk about exceptions in the next part of this talk. So how do we use exceptions? It should be simple, right? Just throw a predefined exception and you're done with it, right? Well, of course not. First thing you do is that you create a custom exception type. So for the same reason, you create custom entities such as user, to-do, order, customer, whatever, instead of using, I don't know, a plain arrays or standard class in PHP, you create custom exception types to bring semantics to your code, to emphasize type instead of exception message. How do we structure exceptions? Well, you keep your exceptions under the exception namespace, and there can be multiple exceptions for every module or a component in your system. As for creating exception classes, so use descriptive names for your exceptions, right? Make a separate exception for every exceptional condition that may exist in your application. Extend exception from one of those built-in exception classes, because when you create exception, the only thing that you need to make sure is that you can throw that exception. I personally always extend my exceptions from base exception class. Some people like to extend custom exceptions from either runtime exception or domain exception, but the fact that you're creating a custom exception type, I really don't see any value in extending it from those types because I'm creating a custom exception type anyway. And you're noticing one more thing, that I'm not using exception as a suffix as part of my name. And I suggest you should not use that neither. Because if you imagine that we did use that suffix, the first thing you are noticing here is that the exception is already a namespace, so you have a duplication between fully qualified class name, right? But more importantly, the very context in which exception is used, so throw, what else can be thrown other than exception, right? Catch, block, also this variable name, that all indicates that we are dealing with an exception, right? So clearly that exception suffix is redundant, and the way to fix this is simply by not using this exception suffix, right? Component level exception type is one very important technique around exception that is relevant, that is important for library code, but is also very relevant for application. So it is a type that can be called for any exception that emanates from a given component. So what does that mean? This technique is achieved using a marker interface design pattern. So typically in some of your component or a module like a user, you create this empty interface, that's why it's called marker, and you have all your exceptions that are part of that component implement that interface. So what this allows a caller is to be able to catch any given exception from a any number of opportunities to catch some exception from a given component. Guzzle is a great example of that HTTP client, right? Because Guzzle is using, it is using that approach. So this class over here is actually a marker interface. These are some concrete exceptions. So what Guzzle allows you is that you can treat client exception one way, server exception one way, or any other Guzzle exception out there some other way. So that's why this technique is super useful, you know, especially for library code. Now, about formatting exception messages. So the problem here is that the logic of formatting exception messages in place where exceptions are thrown can become kind of very messy, you know. This may not seem bad, but things can sometimes get really bad, and your code can become noisy, you know. So the idea is to somehow extract this logic into exception classes themselves. So how do you do that? You do that with the use of techniques called named constructors. My favorite one. So you create a static factory method in the exception class itself. You give it some meaningful name, and you put your formatting logic in there. Named constructors are not only good for the purpose of formatting exception messages, of extracting that logic into exception classes themselves, but they are very good at expressing the intent, you know, because right now, when you are throwing this exception, your code becomes much more readable, expressive, right? It's almost like you're reading some sentence, so throw user not found by username. Also, you can use named constructors for coherent exceptional conditions. So as in this example, where there is a business rule saying that to-do must be open in order to perform certain actions on it. So author of this code has decided to capture all those illegal acts within a single exception class, which is completely legitimate, you know, because this entire exception class is cohesive, which is very important. So next technique is about providing a context. What does that mean? So when you throw that exception and you put some information in it, you pass some information to that exception, like that username, it is a very good idea to allow a consumer of your code to be able to easily obtain that piece of information. So what you do is that you're again taking advantage of the named constructor to put that piece of information into a property, and you expose it via this getter method. So very simple but very useful, right? Because someone may be interested in that piece of information, and you don't want to make that person to parse this message in search of that piece of information. Exception wrapping, another technique. So the problem, the idea here is that your higher level components should not have a clue, should not know anything about the exceptions that are thrown by a lower level component. So, for instance, if you're building some API, SDK for some API client, and you are using Guzzle under the hood, you don't want to let Guzzle exceptions propagate out of your code. You want to hide that implementation detail. You don't want your users to know that you are using Guzzle at all under the hood, because so that you can change your code independent of what consumer of your code is doing. So you wrap that exception into some more meaningful exception for the type of operation that the user is performing. So this API not available exception is kind of more meaningful from a user perspective, because instead of him having to deal with something that would fail here with this connect exception, so some error of HTTP communication failed at port 80, you provide it with something that is more meaningful, like API is not available. And what's very important when you wrap this exception is that you preserve that real error that happens, so that when you log this exception, you have information of what really went wrong in the stack trace of your log, right? So as you can see, exceptions are not that easy, right? There are so many of these techniques that you must follow if you want to make sure that the quality of code around exception is high, because if you are a software architect building maintainable applications, exceptions are also inevitable and equal part of that architecture. So you should really treat them with care, like you treat any other part of your code. And of all these techniques, one that I would like you to take home with you and to start using it on your work is this use of named constructors and unformatting exception messages, because I believe that's the one that will bring immediate value to the quality of your code. So now that we know how to use exceptions, manage exceptions, let's see how do we handle errors, how do we handle exceptions, right? So obviously, one of the ways would be to catch exceptions immediately. But my advice here would be to catch exceptions only if you know how to deal with them in a way that your application continues to work. So only catch exception if you really have a good reason for it. This may sound a little bit silly, but the idea here is that your code, your domain code, should be able to openly raise exception that will eventually get caught by a global or a central error handling system, right? So whenever in a doubt, it's better to just let that a central error handling system deal with that exception. So a central error handler is a uniform and universal solution that allows for managing all the exceptions from a single place. And there are multiple challenges in designing a good and robust error handling system. So, first of all, it needs to provide just enough information to be useful for our users, right? It also needs to suppress any information that is not intended for users, right? So you ideally should not allow to leak some sensitive information in error message that you're serving to your users, right? Some database credentials, for example. You should also log any information that could benefit maintainers, right? Us. And also, it should be adaptable in the sense that your application may support to be invoked through different ports, right? Web, command line, API, whatever. So your error handling system as well should be able to adapt to all those types of interactions. And how do you build one? Well, you can always roll your own by overriding PHP's default error handling system. But you can also use some of the existing solutions that exist, right? One of them is Whoops, which is, I think, very popular within Laravel ecosystem. The other one is Boo, and it has a funny name, huh? Yeah, but the problem with Boo is that it's not actively maintained, right? But it probably has a better code quality when I compare it to Whoops, but it's not actively maintained. So I'm going to use Whoops in my examples. So how do I use Whoops? I use it as any other service in my system. So I create a factory for it. And as you can see, Whoops is a stack-based error handling system. So it has that concept of handlers, and it has a lot of those predefined handlers that are all about formatting exception message. And as you can see, I'm adding them conditionally based on the context using these Whoops utility classes. But you don't need to do it this way, of course, because this is only for the sake of simplicity of this example. And you can also add some custom handlers like these two that I'm going to explain really soon. So now that I have this factory in place, and because of the fact that I am invoking and somewhere in my bootstrapping logic, I get that service, I invoke register on it, and because of the fact that I'm including this bootstrap file in both my web application root and my command application root, now I have a central error handling system set for my entire system, for my entire application. So like I said that in the beginning, one of the requirements of a good error handling system is that it should be maintainable in the sense that you should be able to log all the error messages. So in case of Whoops, you can roll this custom log handle that is capable of logging errors using PSR3 compliant logger, right? But now there may be a case, there may be a situation where for some reason you don't want to log every errors. For example, I may not be interested in logging user errors, client errors, for example, like user not found. I want to focus on server errors, on errors that potentially lead to bugs in my system. So how do you do it? You can have some big list of exceptions that you want to be logging, but that's not maintainable solution, right? So what I do is that I introduce this marker interface that all my exception can optionally implement in order for me to be able to distinguish whether, or this handler, whether some exception should be logged or not. Another one is that when you're building APIs, for example, it is really important that you provide user with a appropriate response code, right? So again, how do you know which exception maps to which HTTP status code? You can have some big map, some big list of errors and their codes, but again, that's not maintainable. I'm always going for a dynamic solution. So again, I'm introducing this interface that my exceptions can implement in order to provide appropriate HTTP status code. So what I wanted to show you with these examples of custom handlers is how maintainable, how flexible your error handling system becomes if you design it this way. So if you need to do some extra processing of an exception, no problem, just push another handler on the stack. If the new exception is added to your system, right, no need to change error handling system itself, but you only implement those interfaces that you've introduced. So in other words, error handling system designed this way is adhering to the open-close principle, right? Letter O of solid. And the last thing I would like to talk about is that I want to shed some light on testing exceptions, on testing exceptional behavior. So how do we test exceptions typically? Well, PHP unit has this handy expect exception a method or annotation. But you may notice that you need to put it before you act on the object that you are testing, right? And this kind of evaluates, like, this is not in line with arrange, act, assert principle that is known in testing. Who has heard of this principle, right? So it is a pattern for structuring and arranging your test code. And even if you didn't heard for this pattern, most of your test code naturally follows this pattern, right? So first you do some initialization of the object that you are testing, you initialize inputs, then you act on that object, and then you verify outcomes. And that expect exception thing kind of violates this principle, and I like all my test code and all my code to be consistent. So how I approach testing exceptions, I mean, some people may think that I'm an idiot that I'm doing this, but at least this makes my test code consistent, right? And also, one benefit that I see with this approach is that your test code kind of looks like an example from your README file, and it's much easier, for instance, to document your application or a library that you're building, because your code in test looks like as the code as someone would use your code. So, and that's pretty much everything I had to say. This, you may be interested in slides. They are on Joined-in. And that being said, I would appreciate if you could rate my talk, give me some feedback, but not only this talk, but all talks that you've attended so far and that you're going to attend, because speakers love that. You know, that's the only way we can improve. Thank you.
Thank you, Nikola. We have 2 questions in top. Guys, I prefer you answer 2.
Can you read one? Which is the first one? I looked for some pattern for handling all exceptions in one place.
Like Symfony exceptions handler for various REST API responses. Can you propose some?
Mm-hmm. Well, for handling all the exceptions from a single place, I guess that someone asked these questions before we reach that part of the talk with central error handling system. So I already proposed two, which one of them is whoops and the other one is boo-boo. You should really give it a try with boo-boo. You may like it more over whoops, but like I said, the problem I have with boo-boo is that it's not actively maintained. Okay.
And next questions.
Where to catch
exceptions in layered architecture, for example, database exceptions?
Like I've said, if you do not know how to deal with that database exception, for example, on your repository layer, for example, if this user repository is based on a SQL database, if you do not know how to deal with that exception that has occurred, you should just let that exception propagate to your central error handling system and be logged there, because anyway, because we assume that you designed that error handling system in a way that it will, for example, suppress everything that is not intended for users. For instance, you would, if that database exception do happen, you would just present it to the user as something went wrong. So you don't want to expose all those details about those errors as you were exposed in case where, for example, user was not found. So in case of client exception, you really do want to show that to the user. But in case of some of exceptions that you're not aware, so like 500 errors, you suppress that, but you log those errors.
And we have time for last one. Have you ever tried to use interfaces in exceptions, which are markers of specific layers on an applications, like application exception interface or domain exception?
I need to read that one more time. Have you ever tried to use interfaces?
Have you ever tried to use interfaces in exceptions, which are markers of specific layers of an application?
I haven't tried to do that, and I would like author of that question maybe to clarify that question further, if we know who is the author of that question. Mm-hmm. Yeah, I mean, the very purpose of that component level exception type technique is just that, to allow you to catch any exception from a given component that is marked with that single marker interface that exists within that component. So I guess I hope that answers these questions in some way. Do you have more questions? I mean, if you have some questions, you can always come to me after my talk and I will be happy to answer all your questions,